Okay, in the last video we summarized how to do Gaussian elimination, and our summary was here. Now notice that this description here is more concisely expressed here, so I'm going to go ahead and erase this part. And just pull this over. And this is the way I'm going to implement my algorithm. Okay? Not that complicated, and you'll see that the program is not much longer than this set of statements. All right, I'm going to go ahead and start up my Scilab. Of course, your computer will be a little bit different from mine. And to type my program, I'm going to want Sci Notes, which is this small icon up here. All right. Now let me restore this down because I want to show my notes here while I'm typing. I'm going to restore this down. Let me pull it up. Okay. It's not going to let me pull. So, all right. The first line I want to do, but even before I do this augmented matrix, I'm going to have to define A and B. So I'm going to make a comment note to myself. Okay, and it's good when you write these programs to use matrix that's simple, so you can tell that the program is doing what you want it to do. So I'm going to write A equals, all right, and I can type in the matrix like this: 1, 2, 3, semicolon, 2, 3, 1, semicolon, 3, 1, 2. Okay. And I'll type in B equals, and I think what I want to use is 2, 0, 4. Okay. The reason I did that was that if you put x equals 1 minus 1, 1, that is x1 equals 1, x2 equals minus 1, x3 equals 1, if you plug that into this system of linear equations, you will get this answer. So I know that my solution is going to be 1 minus 1, 1 when I finally do my Gaussian elimination. Let me point out something here. When you first start up Scilab, if you go to this options here, probably you will have this option of auto-completion and this option of auto-completion checked. I don't like that option myself. What it does is if I try to type in a bracket, it automatically closes the bracket for me, and that kind of throws me off. So I don't like that. I turn the option off by going here and clicking off that option. I also don't like the other option, so I click that off as well. All right, so I'm going to erase this because I don't need it. And I've defined my A and my B. Let's see if we're in good shape so far. I'm going to have the Scilab display these two values. And let me run the program. So I need to save and execute. And let me save it. I'm actually going to save it in this file, gauss_elim_English. Okay. And let's see if it worked. I'm going to go to my Scilab console window. And here we have B and here we have A. It displays them in reverse order. So we're in good shape so far. Let me go back to my editor. And I'm going to go back to my description of the code. And I don't need this display anymore because I've already shown that my results are correct. All right, the first thing I have to do according to this code is create the augmented matrix. So I'm going to make a note to myself, augmented. Okay. And I'm going to call it A, just like I do in the summary. And actually, to make that matrix, all I have to do is just type it like this. I can type A comma B like that. I could actually just type A space B, and that would be fine. All right, so now I want to eliminate the variables. And my variables are going to be xj for j goes from 1 up to n minus 1. Okay, so that's just a comment to myself to explain what I'm doing. Now, here it says loop. To do a loop, we have to write a for statement. You learned that in the tutorial. For j equals 1. The increment between successive j's is 1, so I'm going to put a 1 here. The last value of j is n minus 1. But whoops, I haven't told the computer what n is. N should be the number of rows of A. All right. I happen to know there's a Scilab function called size that gives me the size of a matrix. So I'm going to go here and find out how to use size. I'll type in here size. All right. And we'll take a look down here. And usually it gives some good examples. Right here. Here it says returns the number of rows. That's exactly what I want. N is the size of this matrix, comma, quote, R, unquote. So that's the syntax I'm going to use in my example because I want the number of rows. Let me just go ahead and copy this if I can. I can copy this by hitting Control-C. Hold down the Control, hit the C. So I'm going to close the browser. And I want to type that here because I want to have the size here. All right, now I don't want the size of this matrix. I want the size of A. So I'm going to take the size of A here. All right, now I have no problem because now the computer knows what n is, and I'm all set with n. Okay. Now what this tells me is that inside this loop I have another loop of k. So I'm going to have for k equals j plus 1. The increment between successive numbers is 1. And then we go to n here. All right, now inside this loop, it gives me this equation here. So I'm going to define a matrix A prime. And I want the kth row of A prime. Here I have k and star to indicate all the elements in the row. Here in the Scilab, instead of a star, you use a colon. And that's going to be equal to A of k colon. That reflects this statement here. Minus, and then I want to take this multiplier, A of kj divided by A of jj times A of j colon. All right, so you can see it's very direct translation of this statement here. Enter. Now I'm done with my for loop. I just type end. And I'm done with my second, then I need to reset. So I'm going to set A equal A prime. And then I do end again. And that gives me everything. Now, one thing that bothers me about this code here is I forgot to, the first time I reached this statement, I haven't defined A prime already. So I'd better define A prime above this statement. I'm going to define A prime here. And I'll set A prime equals A here as well. Okay, so let's see how this runs. I'm going to run it. I have to save and execute. And when I do that, I have an error. It says waiting for right parenthesis at line 12 of exec file. So that's pretty clear instructions. I need to go back to my file here. And let's look at line 12. All right. Let's see. Here you can see here all the open parentheses. Here's a closed parenthesis for that open parenthesis. That's good. You notice that it flashes the closed parenthesis when you hover over the parenthesis, so that's good. Whoops, I forgot to close this parenthesis. That's actually supposed to be a parenthesis around the multiplier, so I need another parenthesis right here. Okay, so let's try it again. Okay, and let's see what it tells me now. It doesn't tell me anything, which is good news. It means there's no error in my program. I didn't tell it to display anything. So let me go back here. And at the end of my algorithm, I want to display A. Because that's my reduced matrix, my row reduced matrix. Now, instead of always having to type save, let me just go to here, save and execute. And we'll see what happens. All right. Notice that this is in reduced form. I have the upper triangular form. It's an augmented matrix. So we're in good shape. Now, in the next video, I'll talk about how you now do back substitution and find your actual answer. Okay.